Hello, this is Carl Darch from Let's Really Teach HVAC. This is a Geezers and Gurus on HVAC podcast, and this is an old friend of mine who works for a company called Cochrane, Supply and Engineering. The engineering is the important part. I attended a meeting for smart building controls, a seminar that they had for a couple of days in Detroit. I left it saying, wow, this is the greatest thing since sliced bread, but they lost me. So that's why we're going to be doing a whole series of podcasts. As you can see in front of us here, we have some new equipment here. This is high-tech stuff. Gordon, let's have a look at this thing, which I really like. You see this wheel here? This wheel is not made out of metal, it's made out of wood. So this is cutting edge, 1900
Yes.
technology.
Right.
And when was, you told it was
1883.
1883 pneumatics came in. And as we know from today, Gordon is going to go out and teach a class on pneumatics later next week. But the point I'm making is this was cutting edge technology. And pneumatics was used because it was, first of all, there was no electricity involved. In 1883, that could have been a problem. So all we had is just basic electricity for the motor, and the rest was air through whether mostly high-rise buildings, would you say, or larger buildings?
Larger buildings, yes. And it could be high-rise also. Yes.
And so that was very good. All they had to do was maintain air pressure, didn't have to worry about electrical drop-off and voltage and all of that stuff. These are the original stats from a house that was put up in 1906. The interior is basically the same type of interior that they have today. The principle has not changed. The principle is very simple, and it's still used today all over the place, and it needs to be replaced, and we're going to talk about that in a minute. Here we have, this is a hot deck controller, Barbara Coleman. This is one of two transformers that were used in a residential house. There was actually 6 motors that opened dampers in this house, and they needed 2 of these 25 volt transformers, 375 VA. These things put out some heat, I'll tell you that. But that's only for a small house and 6 motors that they operate. So what's the problem with this? Has this worked? Yes, it worked up until the day I took it out, and was put in 1952, and I just took it out last year or so. So it did work. We're not saying these things don't work. We're saying in today's world, we have fewer people in the field. Everybody's complaining about that. But we need to make a building more efficient, and that means with lighting, right?
Everything.
Heating, cooling, water, everything.
Yes.
The amount of air that comes in and out of the building, which is required by law, but let's do it right. All of this stuff needs to be smarter. We need to be able to have instant information. We need to know how much air is going out of this tube and how much electricity is being used through the motor.
Correct.
We can do that now. We have the technology. And that's what the smart building controls is really all about.
Correct.
Taking this older technology and bringing it up. And you take it from there. Is there anything else you want to?
Well, it's called, the new technology is called the Building Automation System. They refer to it as BAS. But what we have done with everything and what's coming along is there are still, as Carl said, many buildings around that still have pneumatics. And one of the things that's happening in our industry, as Carl said, we have a shortage of people. A lot of people want to do desk jobs and so on and so forth, don't want to get out in the field maybe and get their hands dirty. But there's many buildings that are out there, and as we said, pneumatics is slowly going away. It's still going to be around for a whole long time, just because of the fact that it is back even in 1883, they were trying to make buildings as efficient as what they could, and pneumatics was a wonderful system to get started with. There are very few moving parts, not a lot of stuff going on. It is definitely, as Carl said, done by pressure when you change A thermostat, you're just changing the pressure that's going into the damper and so on and so forth. That might be letting in a little less air, a little more air, and whether it's heating or cooling. But like I say, in our industry today, and with the codes that are out there and building energy management, what we're trying to do is make the buildings as efficient as is possible. And as Carl said, bringing in outdoor air changes per hour is all very, very important in our industry and for buildings. In order to do that, the building automation system came out, and it's coming along, nicely, but it has to be, the old pneumatic system has to be torn out of the system when a building is ready to do it. Pneumatics has been, as I said, very popular. It's still very popular in hospitals. That's one of the biggest places. There are also a lot of school buildings that still have pneumatics.
Churches.
And churches, definitely.
A lot of churches.
And it's, very little trouble with it. There's maintenance to it, but they haven't had a whole lot of trouble with it. And so sometimes it's hard to convince people, to change stuff out. But with the advantages of what building automation systems can do, it's an easy thinker. It's just a lot of money.
We are this whole energy thing in the United States. I'm not going to say anything political about this because it's changing.
Yes.
You can go and stand on the sidelines and cry about it, or you can sit and watch it. But we are going to electrification of cars. Heat pumps are going to be brought in online for much more heating and cooling than it has ever been done before. New technology that has not even been invented yet will be commonplace in a few years. So what are we talking about here? Why the smart building? Well, he was saying there's not lack of people. Here's the other thing. We're going through energy power production.
Yes.
Okay? This unit here, 2 of these transformers, there's a hell of a lot of power that's being put out by that. That in today, if it was done with electronics, it'd be a lot less. The other part of it is, by going onto every motor, every valve, all the piping, everything in this place, and the computer has a sense. We can say AI if you want to, but actually there's going to be a lot of people behind it. But the idea is that type of thing. Intelligence, looking at everything about the building to save as much power, electricity, and water as we possibly can, so we don't have to put up a power plant on every block. We can actually, by making buildings more efficient, we can cut half the energy.
Right, yes.
That's a lot. That is a lot. That's a ton of energy. So we have to start somewhere. The problem we have with these type of units, we don't talk to anybody. If you want to know what's going on in a room, you got to go back up to the thermostat and adjust it. Okay? We know that in your own residential, you could do it off your iPhone now. So with smart buildings, that's what we're talking about, isn't it? Coupling.
Correct.
Everything. Thermostats, lighting control, water.
Security, everything.
Security, yes.
Yes.
To be able to monitor how much carbon dioxide is in the air, so you know how much fresh air, that's how many people are breathing in the place, so you know how much fresh air to bring in without bringing in too much or too little. That's all part of it. Fire protection.
Fire protection.
They even have, how shall we say, security too.
Yep.
It can also be built in there, so if somebody's fooling around, it's all together in a package. It's why we call it a smart building, because it's everything that happens in that space. So we're going to start from this podcast series. It would make it a lot easier if we had, say, a place, a building, that we could come in and say, oh, this is one right here, we can do this. Well, in lightning strike, the way it works, a project has come up, a multinational company that is locally here. I made some contacts with, and it turns out that they are very interested. It is an operating system that is basically useless by today's standards, and most of them are out, but we're gonna get in there and take a look at it and start at A, look at what they have, get a contractors come in and see what they will do, and then we're gonna look at how to practically take a system and that's not working and not efficient, and bringing it up and what we have to do. building we have is all R22, 1,300 tons of air conditioning. 14 or 18 units is what they got going on there. But it's a data processing center, so it needs a lot of AC. And it works 24/7, 7 days a week. They also have other parts of it in there. They use, I think there's over a dozen steam humidifiers on this system to put humidity back in to the air after this 1,300 tons of air conditioning drains the humidity out. That is so that the paper can work in a computer room to process all of the computers. You gotta have a certain amount of humidity, and the printers have to, and the paper has to be a certain amount of humidity. So that's all part of the process, and that's what they have. And right now they got a control system, but it's going to be, Gordon. We got what? We got the engineers here. We're going to salespeople, and we're going to work with the contractors and the engineers. And then how's that project? They make recommendations, or?
Right. They make recommendations, do proposals, and figure out exactly what type of system is best for that particular building based on their application.
Yeah.
So.
Yeah. Because even though it was put in about 25 years ago, let's just give it a round numbers here, 25 years ago, technology has changed so much in 25 years that system is obsolete. Now what we're trying to do with these new ones is it's upgradable, isn't it?
Yes.
It's if something changes, the way the system is working, it can be added. So the advantage is here is we'll have a system in place, and they're not going to, it would be, man, millions and millions of dollars for these people to change out all that equipment all at one time. So we know this is going to be a process. The equipment is 25 years old. We know it's getting to a point where we're going to replace the equipment instead of just repairing it. So at that point, what decisions in a company like this, what is available, look going forward, who is coming up with stuff, that's what we're going to be talking about here. To give companies like yourself and your clients options. So let's say, for example, we, through this process, we come up and say they like the Honeywell control system to go in as the main operating controls or whatever. Well, we know Siemens makes some, and there's other companies. Who else is there?
Johnson Controls.
Johnson Controls.
Honeywell.
So what we're going to do is that they may choose Honeywell, but we're going to have Siemens and Johnson's Control come in and look at the same project and say, yes, but if you prefer, you can do it this way and that way. Because I know that there's many of you guys out there who have had long track records with Siemens or Johnson's or Honeywell or other control companies who say, hey, this is great, I don't want to use that one. So we're going to give you options because Cochrane Supply sells all of them. And it's the best choice for the customer, and the customer's choice is the contractor's choice, because the contractor who is familiar with it and can back it up because of the training and his experience with that brand is what you're actually getting. So every building is going to be slightly different depending on your contractor, but the end result is going to be the same. Massive energy savings across the board. And according to the Department of Energy, that is going to be and is being pushed as law now for 2030, 35, something like that. They want all these buildings upgraded. And that means a big upgrade. We're talking about the building controls here. But we're going to get into other things too, because there's humidity control and other things. That humidity control in these large buildings is just as important as temperature too, for a lot of reasons. So that people do feel comfortable at these temperatures that we have to maintain that might be a little cooler otherwise.
And we started out at the beginning talking about the pneumatics and how it's slowly going away, but it's going to still be around for a while, going over to building automation. But what we wanted to let you know for the fact too is that there's still many years of the pneumatics with people being needed.
Yes.
There's a lot of gentlemen or people retiring in our business. After the COVID thing, a lot of people, I don't know if I want to come back, etc. And there were old-time guys like us that basically knew how to use the pneumatic stuff and work with it.
They were the geezers and the gurus.
And they're leaving, and there's a lot of, people left behind, younger people, have maybe been on the job there for quite a while, but really never got involved in any of the pneumatics part of it because everybody else was taking care of it. I still do quite a few pneumatics classes. There's nothing brand new that's coming out. You're never going to see a brand new a brand new pneumatics thermostat made by anyone. They're the ones that have been around forever.
Yes.
But it's still, as I say, it still is a great system and needs to be maintained and
Maintain it, and there's not all that problems. I mean, interestingly enough, you're dealing with air, so it's an air quality thing, just like anything is. You have a compressor. That's pretty simple right there. And you know that today we don't have compressors like that. You got a tank and everything else. So the tanks get water in them. So you got to have, there's automatic systems to put on to make sure the tanks are dry. But basically, it's the same system from the 1880s. This particular one was not on an air system opening up dampers, but was actually opening up steam valves on a radiator. So every room in this massive 3-story house had a valve on a radiator and a thermostat, and that's what this little compressor did. Why did this thing still works? Why did he get rid of it? Goes back to the thermostat. You got a metal bellows in here, and the metal from opening and closing over a century is cracked. The bellows, so they leak air. So basically, their idea of fixing the job was to get a compressor like 9 times the size of this one and put more air into the system. Otherwise, they'd have to replace all the thermostats. And sometimes people do silly things. So
yes, everything in pneumatics changes by air. As Carl said, if it needs to be more heat in a room, the thermostat will sense it. We'll send that air pressure down to that heating valve. The heating valve will open, allowing heat to come in.
And it could be, you're saying heating valve. So what did you say, heating valve? Well, that could be a steam valve. It could be a hot water valve.
Yes.
It could be a gas valve opening up on a boiler or something else. It's all of that is within the system. Pneumatics, I've done a lot of pneumatics. And tanks and everything else. It's nice working in a vault and figuring out how to get in there after that's another story for another time.
Yeah.
But seriously, there's a lot in pneumatics, churches and that. There's so much there. What happens is that, like he was saying, there's some maintenance that needs to be done. And what happens in a lot of these buildings is we used to have these guys called boiler guys that used to live in a building and maintain the boiler and maintain the control systems and knew what to check on these things. There's some filters involved, a little oil here and there. Not much, but when hard times come, those guys either retired, moved on, whatever. You get a maintenance company comes in, or they don't know this stuff and add them. And that's been going on for what, 20, 25 years at least?
At least, yeah.
At least, yes, definitely since I would say since the beginning of the 80s, it's been getting worse because the churches just don't have a guy full-time on. That's the boiler guy. That's the mechanical maintenance person for that church or the school. A lot of these small schools are the same way.
Yes.
So.
Yeah, I teach at a local community college around here, and the building I am in at the community college, there's still pneumatics in that system. They're slowly changing everything out, but each classroom has its own thermostat, and of course it's covered with a box, so no one plays with it, so on and so forth. But the thing about it is, with the pneumatics, again, that's nice that building automation system is also being able to do. But we can be in this room, and all of a sudden we got to start adding people. Might getting warm, and we can add a little bit of cooling in this room, or maybe the room next door is still empty, and they're just trying to maintain the temperature. Maybe that room needs a little bit of heat. And it can all be done with pneumatic system also, just because of the way the thermostat. So it'll send more or less pressure. If we're opening up, say, a heating valve to bring more heat into this room, it'll open up the valve. That one, it may close it a little bit because they're all satisfied, or maybe it needs more. Ours will close because we add people. Now we've created more heat in this room. So But it's still out there, as I said before, just to stress that there is still out there in our industry between the buildings,
Right.
the churches and the colleges and
And
so
the
on.
other
and so forth.
system that operates that way, but with electricity, is the Barbara Coleman Graduated Electric. And so what they have is, they have the thermistors in their thermostats, and it's the amperage draw that opens and closes the hot and cold deck on an armature on a motor. So you got a hot deck, you got a cold deck. The hot deck is your heating deck. This one was a hot water deck. It could be steam
Sure.
or hot water. And then the cold deck, the one that this one came out of, they had two R12 water-cooled 7.5-ton compressors in this unit. And the house is only 4,000 square feet. So let's do the math on that. You say two 7.5-ton at a 4,000 square foot house. Why would you want that? Well, the guy who owned the house, it was a house with 3-phase electric in it and a full graduated electric system in there. Had a ice rink next to the swimming pool. So the 7.5 to 15 tons was used in the winter time
Yeah.
to make ice. Oh, and the boiler was also grossly oversized, so that in the summertime they could heat the swimming pool. It's all of that equipment is still there. Some of it has been scavenged out and everything, but it was really interesting that when people did this house was built in 1952, and there were no rules. That is what did it, because energy was cheap.
Right, yes.
They have a fresh air intake. It was wonderfully designed because it's a house, it had fresh air coming in there, hot and cold deck, a graduated electric. Oh, it just seemed like a boiler on, off, all graduated, valves opening and closing. The fresh air intake, which was also the first stage of the air conditioning system, so it was closed down when the temperature outside got too high. The grill, this is for a house, was 4 foot square. That was actually drawing into the house, 4 foot square.
Yeah.
And it's open year round, and it's being put in 1952. And if you're saying to yourself, gee, how were the seals on those dampers over there? Forget it. The squirrels loved it.
Yeah.
So a lot of things have changed. The ideas have not. We know we need air, fresh air in. We know it's better if we can regulate that and have hot and cold available and keep it there and keep that temperature comfortable for the people in the room. Now we brought in humidity, carbon dioxide, carbon monoxide, NOx, what else? All
Right.
kinds of stuff. Now, it's all part of the smart building system, along with the lighting. What we're saying is they know where the people are in the building.
Yes.
Isn't that right?
Yep.
So we're sitting here in our little studio thing that we've got set up here. This is one of the training classes. And we're here in the smart building. They would know we're here. They'd know there's only two of us. They would adjust the light and the temperature and all that accordingly. We can do that manually here, but when you have a large building, the bigger it gets, the more you save because you're not relying on a person to go
Right.
and do this.
Yes.
It's the old advantage, I turn my thermostat up and down every day, I always do it. And we know that's not true. You know that about 30% of the time you forget.
There's a little video out by Honeywell. It's pretty interesting. It shows this woman coming into work early and she drives in the parking lot and the light comes on for the security and she gets out of her car and she goes up to the door and has her badge and opens the door, and by that badge that system knows where she works, where her desk is, and as she's walking it lights up the lights just to her desk. The rest of the lights in the building are still off and it goes right to her desk where she can start working and everything, and nobody else around, and it's just the light over her desk that's on. It's pretty amazing what we can do in our industry today in the world. So.
Yes, but it saves a lot of energy.
A lot.
And it means that we don't have to start putting up power plants and it means that we won't have brownouts, and it means that there's electrification that we're talking about. Now, everybody's all talking about electrified cars, oh, lithium-ion batteries. Folks, let me tell you something. The lithium-ion battery is the 8-track batteries. That's where we're at. They have technology now that they're working on. Anybody in our business, and you know what a capacitor is. Capacitors are great. They're on lots of motors, and we know exactly what they do. They give that motor that spark, that boom, to get it going, and that's what capacitors do. But somebody that is smart enough to figure out that you can charge a capacitor like that. The discharge was pretty quick too. Electronically, they figured out how to slowly discharge the capacitor. That's the next series of batteries you're going to see. Last forever, and easy to charge. And if it's a slow discharge, hey, there's 1,000 ways they can do that. You can, at every intersection, they could have just a strip on the highway, pass over, back, it's charged instantly.
Yes.
Instantly. So don't think about the lithium ion. That's something for people to worry about, and we can unslave all of the little children in Africa going for the cobalt. All of that will be gone. This is just the start, just like the carbon battery was a start.
Right.
We had dry cell batteries before that. I remember putting fluids in my battery, in my car battery when I was a kid. You had to keep that up there, or you had to check your battery full.
Yeah, definitely.
So all of the technology is changing, and we're on the start of it. We're just coming into it.
Oh, yeah.
Because they're talking about 80-ton heat pumps. There's no such thing as an 80-ton heat pump. Wow.
Now,
And what's the new refrigerants? They're talking about carbon dioxide.
oh, yes, yeah.
Carbon dioxide is going to be the new refrigerant across the board, and people go, oh, you can say anything you want to about it. But here's the point. All the refrigerants that we got now, which is 43 of them, are basically, how should I say, fossil fuel based. They're made from hydrocarbons.
Yes.
So they're trying to get away from that, and in getting away from that, they're looking for other ways. So carbon dioxide has come up as a way of refrigeration. That's all. It's not impossible. You can get dry ice.
Sure.
And, that's what carbon dioxide is, dry ice. I mean, we can make dry ice, so if we can make dry ice, I'm certain we can use it for refrigeration.
Sure.
It's just the technology just,
Yes.
come on to work.
Yes.
In the heating and cooling business, the technology is exploding.
Yeah.
What you're gonna learn in school to get into the business in 10 years won't matter.
Our technology in that is endless.
But
endless.
it's just exploded. That's why I'm 77 years old. When I went to work for my dad, one of the first jobs I had with him was replacing the fire pots on a gravity coal furnace. And I've also done solar, I've done wood stoves, I've done geothermal. This business is expanding and it's just continuing.